PowerShell Core, any platform, any cloud session. My name is Alexander Nikolic. I'm PowerShell and Azure trainer. I'm also Cloud and Data Center Management MVP and Azure MVP. I'm one of the co-founders of PowerShellMagazine.com, the site that I'm running with a couple of fellow MVPs, and it's a site dedicated to all PowerShell stuff. So it doesn't matter if those things are running on premises or in a cloud. We are interested in PowerShell, and every contribution is actually welcome. So if you would like to write something for PowerShell Magazine, we encourage also new users to do that as well. So why do we need PowerShell Core? Windows PowerShell is pretty awesome, works great, but there is a need for PowerShell Core. We live in a world when we manage heterogeneous environments. We live in a world when the hybrid cloud is something that you need to consider. We need to support a number of different cloud providers, and we need our tools to run on the platforms that we use. You probably heard this a couple of times so far, that we need PowerShell to run anywhere and manage anything. That's the goal. What we got in January this year was the first GA version, PowerShell Core 6.0. And then a couple of days ago, we got also PowerShell 6.1. On the provided link on a slide, you will find also all the supported operating systems. So there's a couple of those Windows ones, lots of Linux distributions, and also Mac. This is a home of PowerShell Core. PowerShell Core lives on GitHub. It's open source. You can see all the code. You can contribute if you want. You can submit issues there. You can submit the PRs. The good thing is here, and you can easily notice that on a slide, it says like PowerShell for every system. Nice motto. The thing that it's even more important for me is the number of releases that you can see on a slide. At the time when I took this screenshot, 52 releases. It's just amazing. It was announced like 2 years ago on the 18th of August. It's just amazing that we got 52 releases in the meantime. Remember those years or days when we waited for a new version of PowerShell for 3 years? Those days are long gone. Also on that link, you can find, if you're interested to look a little bit more of a state of a PowerShell. I presume that some of the PowerShell team members during their session showed the Power BI with analytics of what's happening, how many contributors they have, and from the community and from Microsoft, how many things they are fixed, and how many instances of those are running actually on Linux. And Linux community actually embraced PowerShell Core. They really liked it. So what are the main features of PowerShell Core? First, it's a cross-platform. That's something that was really, really needed. It runs on Windows, on Mac, on Linux, a couple of different distributions. Really, really good coverage. Another thing is that it can run on Windows side by side Windows PowerShell. If you install PowerShell Core on a Windows PowerShell, you will not in any way affect your Windows PowerShell installation. Be aware of that. You cannot ruin it. They're running side by side. It's also portable, which means that you can just download from a GitHub a zip file and install it wherever you want. You can have multiple versions of PowerShell Core at the same time if you use zip mechanism to install it. If you install it using MSI, then you will overwrite the previous version. So be aware of that. If you want it side by side, then a zip archive is your friend. With Windows PowerShell, we had WinRM remoting. Remoting that was pretty good if everything works, right? But also very complex in a way. So if there are some issues there, it was not easy to troubleshoot that. And almost from the day one of PowerShell, people start, or Windows PowerShell remoting actually, people start asking for SSH-based remoting as well. Because that was the protocol that was kind of already in the industry, people really like it. And this is what we got with PowerShell Core. So now with PowerShell Core, we also have SSH-based PowerShell remoting. Later during the demo, you will see how that works and what are the kind of a vision for remoting part of a PowerShell Core and its future. So I would like now to demo a couple of different ways to run PowerShell Core. And I would like to start with installation documentation to kind of say thank you to PowerShell Docs team that did a great job to document all the different ways you can install it on different platforms. PowerShell helps with always really, really high quality stuff, and they are trying to maintain that with PowerShell Core as well. The easiest way to actually get to this page is probably this. You will go to docs.com, which is kind of a starting point for all Microsoft documentation. Then you will pick PowerShell here, go to a reference, and then you will get all the documentation here. Pretty easy, right? You don't need even to search for this. You can easily get there with just 2 clicks. Just start with the docs.com. In installation, a section of this, they cover PowerShell Core. So they documented all the different ways to install it on Windows, on Linux, on Mac, also on ARM platform as well. That's also a part of the documentation. Really, really cool. How can you run PowerShell Core on a Windows machine? What I have here is a Windows 10 machine. So you can install it directly, side by side Windows PowerShell. You will get the PowerShell Core icon. They made it black so that it's different than the blue Windows PowerShell one. And let me check, for example, PS version. Here you see that I'm running 6.1 version, the latest stable version of PowerShell Core, directly now in a console. That's one of the ways to do it. The other thing that I have installed on this machine is Windows Subsystem for Linux. You might have heard about that. It's a way to run Linux command line tools on Windows 10, and they will run like they are native. You don't need to start a Linux VM to do that. It's just another shell that you have at your exporter. So it's really, really cool. So I have it here installed. And this is Windows. I'm using the Ubuntu distribution for it. I installed PowerShell already. And there is also a change, if someone haven't heard about it, that we start PowerShell Core using PWSH, not the PowerShell, okay? They wanted to avoid the confusion with it and to be more as a kind of a bash and Z shell, so like a Linux naming of shells, okay? So you can actually use this thing to kind of a check, do you have a, what's the version that you have, then you just, you start it, and now you are in a PowerShell Core shell inside of your Ubuntu Windows Subsystem for Linux distribution, and you work it, right? So you now have complete experience like you are running this on a Linux box, but you are actually on a Windows 10. Isn't that cool? Really, really slick. One more way to try, and probably the easiest way to try PowerShell Core if you have Azure subscription, is to run Azure Cloud Shell. Azure Cloud Shell is a service in Azure that runs a Linux container for you that provides both Bash and PowerShell experience to you. So here I'm in Azure Portal. I click on this shell icon, and I can choose to run Bash or PowerShell. It will remember the last one you used, so it will start that one. So now I'm in a PowerShell Core running in a Linux container that runs somewhere in Azure data centers around the world. Right now, this moment, they have a couple of thousands of those containers in a standby waiting for someone to click on that link, on that icon. You will get a shell like in a couple of seconds. And then you can use it to manage your Azure resources. You don't need to install anything, and not just PowerShell Core, but some other tools will be available to you. So there is no easiest way to try this immediately without any installations, any configurations. It's just there, pre-authenticated to Azure, and you can just use it, okay? The thing that you need to understand is that it runs on a Linux, so you need to learn a little bit about Linux file system casing. I will talk about it a little bit later. Another cool way to run PowerShell Core without actually installing it on your system is to run it inside of a Docker containers. That's another cool feature. Why? Because once when you are done, when you close your container, your machine is at the same state as it was before you started that container. The PowerShell team, with every single new release of PowerShell Core, release a couple of new Docker images that you can pull to your machine and you use to run PowerShell Core on a different Linux distributions. Well, that's pretty slick. So, for example, I here have already pulled, because I didn't want to wait for a couple of those 100 megabytes to come to me, a PowerShell Core on Ubuntu 16.04 that I can run. So the only thing I need to do is to say docker run -it, which means run it interactively, --rm, remove it once when I'm done, and then specify the URL that leads to that image, PowerShell, and then it's tagged with 610 Ubuntu 6.04. So if I execute this, now I'm in PowerShell Core running in container. Awesome? So easy, so easy. It's just unbelievable how it works. So PowerShell is there. Let's just prove that it's Ubuntu. So it is, Ubuntu machine. That's another way. If you're kind of an old school and you like to run VMs on your desktop machine, that's possible as well. Recently, Hyper-V team released actually a pretty slick Ubuntu image that it's a little bit pre-configured and optimized to run nicely on Windows 10. And what I discovered is, and that's kind of cool, is that, let me just log into this one. When you start the terminal and you want to run PowerShell Core, you get a nice help from them. We cannot find it, but if you run snap install PowerShell, we will install it for you. That's cool, right? I actually didn't execute this command so far. Should I try it? Just to see how it works? Okay, so sudo snap install PowerShell. It looks like include the classic. Okay. As I said, I didn't try it, seriously. This is the first time. Never have experience on this installation on this VM using this method. But I like living on the edge. Oh. So now I have it. Voila. PowerShell Core on Ubuntu VM. And that image is kind of a part of that quick create in Hyper-V. If you haven't tried it, please do. It's just amazing. In a couple of seconds, bam, bam, you have a machine. So this is like fifth way to run it. So many options. Options are good, right? Sometimes confusing, but still, I think it's good to have options. Okay, get back to slides. So the question is, what about Windows PowerShell now, right? It's all rage, all buzz, all hype is about PowerShell Core. You've probably been to a couple of sessions that mentioned that already, or joined a PowerShell meeting, or any of those PowerShell-related sessions, that they mentioned PowerShell Core, right? No one is talking about Windows PowerShell anymore. So Windows PowerShell is still fully supported and serviced. They will fix security bugs if someone finds them, or something that is kind of getting wrong with a new release or something. The story is that it will not be replaced by PowerShell Core, right? So you'll always have a choice to have it run side by side. It's a stable platform for all existing workloads that you have, okay? No new features are also planned. So it is what it is. That version that we have just runs, and you can continue using it. If you decide, and there is no reason not to try PowerShell Core now with the version 6.1, you can just easily run both of them. Also, the question is very often, will they port SSH remoting on Windows PowerShell? The answer is no, for now. Maybe they will change it, but for now, this is what it is. Another question is, what's happening now with the PowerShell ISC, right? So far, our favorite PowerShell editor. What's the future of PowerShell ISC, right? And the thing is pretty much the same. No new development of PowerShell ISC, no innovation in that area, only bug and security fixes. But luckily, we have a future PowerShell editor. That's Visual Studio Code in combination with the PowerShell extension. That's the one that you should start using almost now, just to prepare yourself for the days that you will move to PowerShell Core. I seriously encourage you to do that. It's just beautiful how it works. It provides some features that you don't have in PowerShell ISC. One of the most important ones is a connection to a GitHub. We miss that in PowerShell ISC, right? Connections to our source control systems. You can easily install Visual Studio Code together with extension just by downloading, installing, and then running install-VS Code script from a PowerShell gallery. Do we have someone in the room that never tried PowerShell gallery? Good. This is what I expected. No hands. That's awesome. OK, so let me show you how that looks like for people that never actually look at the Visual Studio Code in combination with PowerShell extension. So once when you install it, and to make it easier for you to make the transition, I picked the PowerShell ISC theme for Visual Studio Code. Isn't that awesome? I probably tricked someone who is kind of sleepy a little, right? It looks like PowerShell ISC, right? So with it, you get this PowerShell integrated terminal. You open your PS1 files, which is also cool here, that you can actually open a folder with all your scripts and treat them as a project, or a workspace, as they call it. They also have a way for you to change different settings for extension if you, for some reason, are not happy how it behaves. It's the PowerShell extension for Visual Studio Code is also open source and hosted on a GitHub. So you can complain there and submit your issues, or if you are knowledgeable enough, you can actually help to all of us and fix something and submit a PR. That's the beauty of open sourcing all those things around PowerShell, that we can now play active role in the development of it, right? So you will see through the other demos how it actually works, but I want to show you one thing that it's absolutely amazing when you run it on Windows. You can easily, from a GUI, change versions of PowerShell that you want to use. The only thing that you need to do is you need to click here. It's bad with the tooltips. Let me do it this way. So if I click on 6.1, which is loaded, we are talking about PowerShell Core, I have a chance to switch back to Windows PowerShell if I want. So you can have your local script open and then run it in a terminal that runs in PowerShell Core, and then switch back to Windows PowerShell and run it there just to see if it works in both environments from the same editor without doing anything else, just clicking and picking different version. Awesome? Great stuff, really. So cool. And if you have multiple versions of PowerShell Core, they will also show up here. So you can switch between, for example, 6.1 and 6.0 and change, OK, something is breaking for you, or you think it's now broken in 6.1, you rerun it in 6.0, then you realize that it breaks there as well, so it's not Microsoft's fault. It's really, really good. I really like how it works, and you will see with some other demos that it's very, very useful to use. So what are the limitations of PowerShell Core? Some modules are still incompatible with .NET Core, and few built-in commandlets are missing. They will probably not even return to a PowerShell Core directly. So for example, WMI first version commandlets, perf counter, event logs, local accounts are missing, but on a Windows, there is a magic to return them back somehow, and I will show you that very soon. On the non-Windows platforms, they also removed a couple, SIM commandlets, Azure-Management, and PS diagnostics. They also removed the old technology called snap-in and removed the workflows. Okay? So module coverage is really important here. Why? Because the success of PowerShell Core is actually your success. If you are not successful using PowerShell Core, that means that they failed, right? So they need to enable you to run everything that you ran before when you used only Windows PowerShell, right? So first, when you look at the Cloud Shell and what's happening there, you can see already some of the new things. PowerShell team is working closely with Azure, Windows, and Office teams to bring all those modules that were created to run only on Windows PowerShell to run on PowerShell Core to run cross-platform. When we look at Cloud Shell, we will see a new set of modules for working with Azure resources, a new one for working with Azure Active Directory as well. When we talk about Windows PowerShell, then if you run PowerShell Core 6.1, and you don't have the latest or those insider versions of Windows 10, you can use Windows compatibility module, install it from PowerShell Gallery, and it will provide to you a transparent implicit remoting targeting your local machine, and they will actually fetch the modules from Windows PowerShell. It's genius, seriously. It's just, who said that? I was like, wow, man, it's like employee of the year. Great stuff. On PowerShell Core 6.1, when you run it on Windows 10 version 1809 or one of those recent insider versions, or Windows Server 2019 that will be GA in October, you don't even need to use that one. You will immediately have access to 1,900 and more existing commandlets. That's pretty cool, right? So let me show you how that works. So here I have a demo for Windows compatibility. So I'm on a Windows 10 machine, the stable release, no insider, nothing of those. I will try to use GetNet adapter, and I'm getting error message that it's not recognized. The PowerShell Core is not aware of the existence of that module that contains that commandlet on my machine. Okay? Then I will look at get local user, same experience. Let me go and check the content of PS module path. You will notice, ignore the fourth and fifth. They are there because I'm running it in a Visual Studio Code. Concentrate on the first three. The first one is for my personal current user modules. Then I have one for all users and one with the system modules for PowerShell Core. But then, sorry, don't ignore the fourth one. That's the most important one. I made a mistake. That fourth one is actually pointing to Windows PowerShell modules. So that the PowerShell Core will be, with the magic of that Windows compatibility module, able to load those modules and commandlets that belong to them to a PowerShell core. What you need to do is, I can actually miss that. So find Windows compatibility. This is how you will find it on a PowerShell gallery. And then you will install it. I already did that. So let me show you what's inside. What are the functions in that module? The one that it's really important for this demo here is invoke win command. Very similar to invoke command that we use for PowerShell remoting. So if you want to run getNet adapter, you just need to put it in a script block and run invoke win command before it. So let me do that. And magically, woo, we have getNet adapter, right? So let me try that with get local user. You see the magic here. The first part of this pipe runs thanks to that Windows compatibility module in transparent implicit session over remoting stack, and then I pipe that to a local select object that is PowerShell Core commandlet. All right? How is this possible? If we look at get PS session, you will see that this is created for us, that remoting session, and they use that one to reach a Windows PowerShell modules on Windows PowerShell and execute it in this environment. Very, very nice. Let me show you how that works in this is a little bit weird with this. For some reason, it stops. Let me try again. Okay. So here I have one of the recent preview versions of Windows 10. Let me show you what the version is. Run selection. It's 17744. When I look at the PS module path here on this machine, you can recognize again that I have the Windows System 32 Windows PowerShell v1 modules path there. So that means that I can load the Windows PowerShell modules to a session. So now, without that invoke win command, I run directly getNet adapter, and it runs. I run get local user, and it runs. Right? That's pretty cool. How they managed to do that? They changed the module manifest and added a new property called compatible PS editions that can have two values, core or a desk, short for desktop. Desktop meaning full Windows PowerShell based on .NET framework, okay? So if the value there is core, that means that Microsoft tested it and it works in PowerShell Core. They won't stop you, but it's on you to load it if it's not marked as core but just desk. But then you can test it and kind of provide a feedback to them. They like beta testers, like that's pretty cool as well. So let me show you how many we have if we include the check and see it. So on my system, we have 57 modules that I can load in PowerShell and use in PowerShell Core. If I skip that check, the number is a little bit higher, and the number is actually, I think, 92 or something, 92, okay? How can you check? You can say, for example, get module list available, skip additional check, and then do a filtering to get all of those that are missing core, to see the ones when we still need to talk to product groups and persuade them to change their things so they will run in PowerShell Core, okay? What is really interesting here is that if I run, sync commandlets exist on a PowerShell Core on Windows, okay? So what's happening when I run this without including that check, I get access to version 6.1 of sim commandlets. But look what happens if I skip addition check. I actually get listed both versions, the one that runs in Windows PowerShell and one that it's created and updated for PowerShell Core. But how they manage not to have a confusion and a conflict with that, if you look at the PS addition column, you will see that for 6.1, it's Core, and for 1, it's desk. So the desk one is not visible to PowerShell Core. So you cannot have a conflicts and problems. How to write scripts and modules that work everywhere? That's an interesting question, right? Because now that PowerShell Core runs on Windows, Linux, and Mac, we need to look at some of the specifics for those new operating systems. One of the first one that we need to pay attention to is case sensitivity issue, right? PowerShell is mostly case insensitive. I say mostly because there are certain cases when you will have a problem if you don't pay attention, right? For example, if you work with XML, you need to pay attention because XML is case sensitive. Or there are a couple of other cases, but that's kind of like a 1% of things. So the best practice is use casing that exists on Linux. Why? Because Windows doesn't care, so that will work there, but Linux cares, and you will fulfill that if you pay attention. So for example, use path with all capitals, right? That will work on both. We also have a number of automatic variables that we can use in our scripts to do some if statements and then target different ones if there is a need for it. So they have is core CLR, is Linux, is Windows, is Mac, right? And you will see them a lot when you look at the cross-platform scripts provided already by others, for example, on a GitHub or on a PowerShell gallery. They use them a lot. Environment variables. Do you know why I put word environment all capitals? Because on Linux, that's kind of a standard. So pay attention to PS module path. That one is not all capitalized. It's actually like this on a screen on both Linux and Mac. They also introduce a new statement, parameter for requires statement. So if you want to target just PowerShell Core and you know that it runs only on PowerShell Core, you can actually specify in your script hashtag requires -ps addition core. So if someone tries to run that not on a PowerShell Core, but on Windows PowerShell, they will get an error message, right? Or vice versa. Another beautiful thing here is that instead of hard coding certain values, use .NET Core types. So .NET Core to the rescue. Why? For example, the path separator on Linux and Mac, on Linux and Windows is different. On Windows is a semicolon. On Linux is a colon. So instead of you checking what it is, leave that to .NET Core. You will say system IO path or just IO path, colon, path separator. And that .NET Core will pick the right one for the running operating system. Isn't that cool? I really like that. Or if you need to combine certain strings to create paths, you don't want to think about, oh, is it a backslash or is it a slash, right? You can use, for example, the method combine for it. And there are a couple of other interesting types, like environment and the Microsoft automation platform. So let me show you, I don't have a demo for it. Okay, I had a demo for it. Let me show you demo quickly. So 8, because I want to show you something really, really magical. For real, I'm not joking. And you will be surprised too, I think. It will be one of those moments, I think this deserves applause. You will see. So now, I'm in Visual Studio Code. The terminal is PowerShell, PowerShell Core. Look at this. I have here a feature called split terminal. So what I have here right now in front of you is one terminal, Windows, one terminal, Bash. What's happening when I run here? This. I have PowerShell Core loaded here. Let me run PS version table. Let me run PS version table. Oh, something weird is happening. It's jumping a little. Look at this. In the same GUI, two terminals running PowerShell Core, one on Windows and one on Linux. Isn't this magic? Absolutely brilliant stuff. Why? Because you can now very easily test your scripts in two different environments, all of them running in the same editor. For example, let me go a little bit quicker through this. I mean, those are the kind of snippets of code that I took from the real world. Those are from the scripts that are running in a Cloud Shell. A Cloud Shell is that Linux environment that runs PowerShell Core and all that, so you can see how they use is core CLR or is Mac OS using get variable, for example. This is a little bit about casing, but this is the one, path separator. So I will now execute this one in PowerShell Core on Windows. As you can see, it's a semicolon. I will now switch to PowerShell Core on Linux. And it's a column, right? So you can use this technique to check the other stuff. You can run combine. On a Linux, you will get forward slashes. If you can run it on a Windows side, you will get backslashes. So it's on them. You don't need to hard code anything. There are no if statements. It just works thanks to .NET types. Really, really cool. Let me get back to PowerShell remoting. We have a really nice demo with it. So with PowerShell remoting, we have a couple of different ways now in PowerShell Core. We can still use PowerShell remoting over WinRM. We can use it over SSH. This is a new thing. Or we can use the plain SSH remoting as well. There are a couple of limitations here still that the remoting based on WSMan are still experimental or non-Windows platforms. And they still don't support the Kerberos. The hypothesis here is that the SSH is actually the future of remoting. The WinRM will still be important and still be used, but let's move to SSH, because now we can run SSH remote targeting Windows and targeting Linux machines from a Windows and from a Linux. So let me show you now a demo of SSH remoting when I will run my commands against the Azure VM that it's Linux Azure VM, okay? So I will need to open Bash in a Cloud Shell. This is also one, seriously, like when that happened to me for the first time, I was saying like, man, they're talking about rainbows, they're talking about unicorns and all that. This is really magic. There is a terminal running in some Azure data center that I can bring to my own local environment and treat it just as another shell, right? So how that works, you need to press Control-Shift-P, say open Bash in Cloud Shell, and it will open as just third terminal. So I have Bash, I have PowerShell Core here, and I have Cloud Shell, right? It's fantastic. So what I need to do, and I did that a little bit before a session, I created a resource group and I created a Linux Azure RM. So those are the things that you would need to do. This is more like instructions when you later look at the code so that you know what you need to do. The good thing here is that you can also generate SSH keys immediately during the creation of the Azure Linux VM. What we will get by default is Ubuntu 16.04. So after that, the steps that you need to perform, which I already did, is you need to install PowerShell Core on it and configure SSH for getting a PowerShell call for it to support the PowerShell. So those are the steps that you need to do. You need to import public repository keys, then register your Microsoft Ubuntu repository, update the list of products, install PowerShell, and then just run it. So you have 4 steps between you and PowerShell Core on Linux. Very, very easy. Once when you have that, you need to configure sshd_config file in a way to add subsystem that will point to a PowerShell Core. So the command for that is this. Here, line 44. Subsystem PowerShell, user bin, pwsh, ssh, no logo, no profile. And then you restart a server. From that point, you can use PowerShell Core to target your machine using SSH remoting. Okay? That would be enough if you want to have a password to log in, but if you want to go with the keys, which is the right way to do it, then those are the steps that you need to do. You will generate keys on every client that you want to use, and then you will put them on that Azure machine in a file called authorized keys so that you will allow connection, okay? And you need to do that for every user that want to connect to that machine as well, right? Because they will have their own private keys. So once when you have that, you can use absolutely the same command to connect to that Linux Azure VM from Windows, in this case, from Ubuntu, that it's part of my Windows subsystem or Linux on machine, or from a cloud shell. Absolutely same command. That's just amazing, mind-blowing thing, really, if you think about it. So what we have here is, first, let me just show you the terminals that I want to run this. So the first one is running in PowerShell. I can remove this one. Oh, cool. Unexpected. Let me restart that. OK, we are back. So what I have here is a new set of parameters that support SSH remoting with the parameters host name, username, key file path. So I say new PS session, host name, provide IP address of my Azure VM, demo user, and the key file path pointing to my private key, and then storing the information about session into a variable so that I can reuse it later, okay? So let me run this. Now I have a session. What I can do with a session, I can use it like invoke command, ICM, session. Let's use GPS get process to see the number of running PowerShell Core processes on that Azure VM. The number of processes is 1 for now, okay? Let me now switch to my bash terminal. Now I will run the same command targeting bash. The first thing I need to do, it's actually in the notes, I need to start PowerShell, right? So the PowerShell Core is running. I have a session. Let me, nope, not there. Let's switch here. ICM, session, GPS, PWSH. The number of running processes, 2. 1 from Windows, 1 from bash. And now, for grand finale, let's move to PowerShell integrated, to a Bash in Cloud Shell. Let's start PowerShell there. Send this command there. Oh, okay. We have a session. ICM. Session, GPS. And we have 3 now. From 3 different platforms targeting same machine, we can now run whatever we want in that Azure VM. Did we like it? So how can we provide feedback in Contribute? Once when you download these slides, you will get all these clickable links here that will lead you to a PowerShell Core on the GitHub official documentation, repository that they use to build all those nice Docker images that we can use, PowerShell extension for Visual Studio Code. You can also participate with the call for comments documentation when they discuss new design moments, or join us for the PowerShell Core community call. The ICS file is provided at that link so that you can join the call. If you try Windows PowerShell modules and they're not working, you have module coverage here for a feedback. And please contribute to PowerShell Gallery with your work. Thank you for your time, and please don't forget to evaluate the session. Thank you.